Hello, class. We are back for the last part, hopefully, if the internet doesn't cut out, of our chapter 1. So I'd like to go over some of the theories of development, but then I'd actually like to move us into some of the ways in which we are studying and collecting data in developmental psychology. Okay, so I talked to you just now about some of the different basic theories. Your book actually goes into significant detail on different types of developmental theories. And I would highly suggest spending some time with those and really looking through them. If you have any questions over those theories, I'm very, very happy to have a discussion with you about those during class. So make sure that you bring any of those questions with you. So when we think about theories in development, first we need to think about how do we come up with theories? How do we come up with hypotheses? Well, we do this using the scientific method. If you have taken a basic science class in elementary school, you know about the scientific method. And essentially, it's a 4-step process, right? So the first is that we have to think about or conceptualize a process or a problem that needs to be studied. The second is then that we collect research information, we then analyze the data, and then we draw conclusions. But in order for us to be able to engage in that scientific method, we really need to come up with a theory. So this is sort of the framework by which to work under, to kind of come up with this idea that we want to test. So the definition of a theory is an interrelated set of ideas that help to explain data and make predictions. I consider a theory to be sort of this umbrella term. It's almost this overarching idea. From this theory, we can come up with hypotheses, which are assertions or predictions that are derived from the theory that's being tested. So these are going to be our much more specific questions. From there, we can then move into the scientific method, which is collecting that data, analyzing it, and then drawing conclusions from it. While your book actually has several different theories that are typically known in developmental psychology, we are going to be taking more of this eclectic theoretical approach or orientation. And the reason for this is all of these different developmental theories that we have been exposed to are going to be meaningful to us. And when we think about this eclectic theoretical orientation, the basic idea is that lifespan development is complicated. Thinking about people and why they do what they do is complicated. Each theory that you're exposed to in chapter 1 does contribute to our understanding of development. And specifically, by using this eclectic theoretical orientation, we can select the best features from each of these different theories. In fact, arguably, it might be a mistake for us to rely only on one theory when we've got so many really great ones that have been created in the past. Okay, so thinking about a theory versus data, sort of going back to this idea of our theory is an organized set of principles that allow a person to describe and explain some aspect of an experience. So what makes a good theory? A theory is considered to be good if it is falsifiable. And what does that mean? I should be able to disprove it. You may have heard this if you've taken other classes with me before, but I think it is one of the best examples to really showcase this idea of falsifiability. So back when the plague was in existence, the known sort of cure, or the, at that point in time, thought cure for the plague was bloodletting. It's exactly as it sounds. Individuals, doctors would come in, they would let your blood, they'd cut you, and then they'd let your blood. And the idea being that all of the bad, impure blood would be drained from your body, and then it would be replenished with good blood. We now know that that's not how the plague worked, or how disease progression and illness tend to work. But at that time, that was the working model. This would be an okay model if the theory could be disproven. So what do I mean by that? If you got better, they would say that the bloodletting worked. If you didn't get better, technically, we should say that the bloodletting didn't work for you, right? But that's not what happened. At that time, individuals actually said if the bloodletting didn't work, you were too far along in your disease progression. This is a big problem, right? Because now there is no way for me to disprove that bloodletting doesn't work. And so in this case, my theory is not falsifiable. It's not really a good theory. Going back to our previous slide, our hypothesis then is going to be this testable prediction about the conditions under which an event will occur. And this can be derived from other general theories. In general, a theory should be parsimonious. And it should have good heuristics, meaning it should be easy to understand and it should be succinct, right? So we should be able to describe this without a lot of jargon, without 15 different sentences. It should be quick and to the point, and we should be able to understand it. And a good theory, kind of going back to this heuristic, should be able to evolve over time. We should be able to modify it. We should be able to drop information that kind of mounts against the theory. And this is ultimately what creates a really, really good theory. So how do we actually study this development? Well, of course, we're going to use the scientific method, which we had outlined in our previous slide, right? So thinking about the problem, collecting data, analyzing that data, and then drawing conclusions on it. So there are some commonly used research designs, and I think that we should be aware of them. The first one being a correlational design. Correlation is when we see an association between two different variables. It is important to remember that correlation is not causation. One of my favorite examples of correlational research design is using the song by Biggie, where he says, the more money we come across, the more problems we see, right? So more money is related to more problems. So if we take a look at this, this is a correlation. Biggie actually argues that the more money that one has, that there happens to be, so we have an increase in money, we're also seeing an increase in problems. This is actually a positive correlation, right? Increase in money is related to increase in problems. But Biggie is not telling us that more money causes more problems, right? We can't actually say that because all we're noting here is a relationship between two items. Here are some other examples of correlations as well. So we've got things like how long a lecture is and how many yawns we see from students. This would be a positive correlation. We can see a negative correlation, which is looking at the length of a lecture and how attentive a student is. So the longer the lecture, as we have an increase in the amount of time in a lecture, we have a decrease in the attentiveness of a student. This is what we would say is a negative correlation. Okay, let's go down here. Here, we also see another negative correlation. We have the number of parties as a relationship to test grade. The idea being that if we see an increase in the number of parties that one attends, we'll see a decrease in the test score that a person has. Okay, and then let's do one more. Here's a positive correlation. The number of hours we spend studying is correlated with our test grade. Specifically, the more hours one spends studying, the higher their test grade is correlated with higher test grades, right? Or relationship with increased test scores. So we have an increased amount of studying is related to an increase in scores on an exam. I can provide you with lots of different examples kind of looking at this. Here's another example looking at the number of hours that one spends practicing and the amount of errors that they then have at a piano recital, right? So the more hours that we spend studying, the less errors that we would have. Here's one looking at the number of hours a person works and the number of tips they receive. So here there's a positive correlation. The more hours I work, the more tips that I tend to get. But we can also have a relationship where there's actually no correlation. So for example, let's say I wanted to look at the relationship between the number, a person's grade point average and the number of times that they wash their hands. If you thought to yourself, how are these things related? You'd be correct, right? There's no relationship here. There doesn't seem to be anything kind of linking these two things together. So this would be a correlational design. Now, as I had talked to you about previously, I can't assert causation with a correlation. I can merely say that there's a relationship. But in research, we very often want to assert some type of association, or we want to say that there is some type of known relationship. And so in this case, when we want to look at causal behavior, we actually have to move to a experimental design. And this is where we are actually engaging in a study, and there are two things that are really important to have a experimental or true experimental design. The first is random assignment, and that means every person in your study has the exact same probability as every other person in your study of being in either my treatment or my control group, right? So if I want to say more money causes more problems, I would have to randomly assign individuals to be in one of two groups, right? Or multiple groups, depending on how I want to do it. So in one group, I will just take a look at, the money they have and the problems they have. But then if I really want to do a true experiment, I would randomly assign people to different amounts of money and see how that relates to their problems. This is when I would get into a true experiment. So in this case, I might give some people $1,000 and then I measure their problems. Another group I give, $200,000 and they measure their problems, and so on and so forth. If in fact having more money causes more problems, then the group who has the most amount of money should report having the most amount of problems. But in order for this to be a true experiment, I should be able to randomly assign people to each of these groups. They shouldn't be able to self-select. Random sampling then means that I should be able to, whoever's a part of my research study should be representative of the larger population. So if in my study, I only sample, let's say people, I live in this rural area in Northeast Ohio, and I do this study there. Is that representative of the population of the United States? Well, the answer to that should be no, right? And so then there isn't much generalizability there. So my sample should also be very representative of the sample in which I'm trying to compare my research to, or that I'm trying to collect data in. Okay, and then I should have an independent variable and a dependent variable. And what does that mean? In any experimental design, we should have an IV, and that's related to my DV. An independent variable is the variable that I'm trying to manipulate. So when I'm looking at money related to problems, what am I manipulating? I'm not manipulating the problems people have. I'm manipulating the money that I'm giving people. And I'm seeing if the amount of money that I give people influences the amount of problems that they have, right? So I'm seeing how my independent variable, the variable that's being manipulated, influences my dependent variable. So my DV then is going to be measured in my experiment by how it's affected by the independent variable. So let's take another example here. Let's say I have this brand new program, and I want to see if the amount of time a person spends in this program, if it's related to how quickly they can complete an assignment that I give them. So my independent variable, right, is what I am manipulating, right? And my dependent variable is going to be my outcome. So in this case, my IV is going to be the amount of time that I'm allowing each participant to spend in the program. And then I give everyone the same assignment, and I see how quickly that they can complete it. Now, if I'm assuming that the more time you spend influences how quickly you can complete an assignment, if that's what I'm hypothesizing, then those individuals who spent more time in the program should be able to complete the assignment in a quicker fashion. Now, in an experimental design, I could have something called a main effect. And this is where a level of my independent variable produces differences in my dependent variable. So let's say, for example, I have the age of my participant. It's not something that I necessarily was manipulating, but maybe, let's be stereotypical here, a person who is younger, even though they spend less time in the program, are actually able to complete the assignment quicker just because of exposure to technology, right? So I might have a main effect of age. All right. So another commonly used research design is a field experiment. So here I'm actually conducting my experiment in a setting that's occurring out in the field, right? And so here I'm doing it more in a natural setting. Within this kind of field experiment, the natural setting is really, really important. Our external validity then will be high because now I'm looking at it in real life, but it can be harder to control. And so again, we have trade-offs for the types of experimental designs that we are using. Okay, so I want to leave us with one of the last pieces, which is some other research designs that we can use. Okay, and we see this very commonly and very often in developmental research. So there are three things here: cross-sectional designs, longitudinal designs, and sequential designs. Cross-sectional designs are where we're going to look at individuals of different ages compared at one time. So maybe I look at 2-year-olds. So I look at how fast kids are acquiring language. And I do this by assessing 2-year-olds and 4-year-olds and 6-year-olds and 8-year-olds. And I do that all at one time, meaning that during my experiment, that the time that I'm collecting the data, I bring in kids from all of these different age groups. And then what I do in my analyses is I compare them with each other, right? So I compare how my 2-year-olds perform to my 4-year-olds, to my 6-year-olds, and so on and so forth. In a longitudinal design, I'm looking at this same kid over time. So I bring the kid in at time 1 into the lab at 2. 2 years later, when the kid is 4, I bring them back into the lab. And then at 6, and then at 8. And at each of these different time points, I give them the exact same experiment. I give them a list of words, and I ask them if they know them, right? Or I'm asking them to produce the amount of vocab. So just tell me every word that you know, right? So I'm doing the exact same experiment at each of these different time points. The last is our sequential approach. And this is where I'm combining my cross-sectional design with my longitudinal design. And what that means is now I'm at time 1 looking at 2-year-olds, 4-year-olds, 6-year-olds, and 8-year-olds. And that would be my cross-sectional. But then I'm also collecting longitudinal data. So now I follow these kids for the next 4 years. So now I look at 2-year-olds compared to 4-year-old. I follow the 2-year-old as they become a 4-year-old, as they become a 6-year-old, as they become an 8-year-old, and so on and so forth. But now I can compare. So not only do I compare the different ages with each other, I can actually compare them as they are transitioning and growing. And there are positives and minuses to each of these. So with our cross-sectional design, this really hints at some of the developmental trends that we might see. But we could see something called cohort effects here. And a cohort effect would be something that affects a group of kids. So they actually did a study similar to what I described, where they were trying to look at children's language acquisition and their ability to understand vocabulary. And during this, they found a lot of these 6-year-olds and 8-year-olds knowing the word provincial, but when they looked at 16-year-olds, most of the kids didn't know what provincial was. Well, it turned out that Beauty and the Beast came out around the same time, and Belle was talking about her provincial life. And so all of these kids, 6 and 8-year-olds, maybe even 10-year-olds, were watching this movie, and they were able to pick out and knew what provincial was. Now, if we didn't have that context, we might assume when we looked at the data that our 6-year-olds, 8-year-olds, and 10-year-olds are geniuses, maybe, compared to our 16-year-olds. But that wouldn't be correct, right? There's something that's happening that affected that group of kids in our research study. Our longitudinal design is great. It really provides us with information of that development over time. But the problem with this is it's extremely expensive, and it might not be necessarily representative. There might be also cohort effects here as well, right? We're just following the same kids over time, so if something were to influence that cohort, we might not actually know the difference. So sequential designs are kind of the best of both, right? Because now if there was a cohort effect, I would find it because I'm following different groups over time. But there's still a problem with my loss of my participants. It's extremely expensive to conduct this type of research. Primarily, you will see a lot of research done with cross-sectional, longitudinal, and sequential designs, particularly some of the earlier research in developmental psychology. This is very common because we're trying to look at how one changes or evolves over time. And these are some of the best ways for us to be able to do that. So there are some other ways for us to collect data over and above what I've kind of shown you. And I want to just make sure that you are aware of them. Your book goes into a little bit greater detail with these, and I'm also very happy to answer any questions that you may have on any of these specific methods. I just wanted to make sure that you were aware that they existed. All right, so this brings us actually to the end of chapter 1, at least our sort of condensed lectures. I've posted the complete lectures for you in Canvas, so please do take a look at them, spend some time looking through that research. And of course, as always, if you have any questions, feel free to let me know and ask me. Of course, our class time will be the best place for us to ask these very detailed questions. So I look forward to seeing you in class later this week, and hopefully we'll have a lot to talk about over this chapter. Enjoy the rest of your day, and I will see you soon. Okay, bye.